Okay, so wastewater treatment, secondary treatment. So as I mentioned before, secondary treatment we use the biological treat. This is we utilize the biological treatment process in which organic microorganism will convert the organic matter, okay, into inorganic matter. So meaning that non-soluble solid to soluble solid. And how we do it? So this is a secondary. So in here, this is organic matter. This organic matter. So it will be uh, removed by this is the bacteria. Okay, the the bacteria. So it will be removed. It will be consumed by the bacteria, and the bacteria will from the bacteria residue from the biological process will become like solid, soluble solid. So soluble solid inside the wastewater, it still have the organic matter, small organic matter, okay, small solid organic matter. So now it become, and then the wastewater itself is sticky. You know, viscosity is high, and it's a little bit sticky. So this is we call it settling type 2. So it will become flock. Okay, so flock. Now this is small with the small, and it become flock, and this is a medium solid, and then become large flock. Okay, and then if we go to the next tank, which is we call it a sedimentation tank. So final sedimentation tank, which is clear water and a large flock, and become slush. Wastewater secondary treatment. How this accomplish is create a very rich environment for growth of diverse bacteria community. Okay, diverse microbial community. So meaning that in the secondary treatment, we try to assist the bacteria to have a rich environment for growth. Okay. So in the secondary treatment, we have a high density of microorganism and good contact between microorganism and waste, provide high level oxygen and favorable temperature, pH, nutrient, no toxic chemical present. Temperature, pH, favorable temperature, pH, and the nutrient. So this is important. Why? Because you know, some the growth of bacteria is need like specific environment. So certain temperature is needed, certain pH is needed. So that's why we need to know the characteristic of the bacteria, so that we can provide them with, with their environment for the growth, for their growth in the maximum condition. Okay, basic approach is to use anaerobic biological degradation. We have organic carbon plus oxygen. Where the oxygen come from is the tube that we inject the oxygen inside the tank. So the oxygen plus microorganism, it will be CO2 plus water plus inorganic matter. So two methods of treatment. We have dispersed growth, or we call it suspended organism, and fixed growth. This is a attached organism. So dispersed growth can be, the method can be activated slush, it can be oxidation dish or pond, and fixed growth it can be trickling filter or rotating biological contactor or BC. Activity slush, you can see here. This is activity slush. So the slush come from primary treatment, primary treatment. Okay, so primary treatment, and then after that we go to the primary settling tank. So from this from primary settling tank, we will go to the aeration tank. So here the oxygen will be injected into this tank, and then after that the secondary treat, we will go to the secondary settling tank, or call it the final settling sedimentation tank here. So some portion of the sludge in here, it taken will be taken or will be moved to the aeration tank. So as I mentioned before, to increase the growth of the bacteria. And after that, the solid will be collected in the anaerobic in the sludge digester here. You know what is this? This is a heat. So because to increase the process, the temperature, high temperature is better, but if very high temperature is not good because it will kill the bacteria. So it needs like a very optimum condition for the bacteria, for the anaerobic bacteria to achieve their work. So activated sludge. So activated sludge refers to the biological treatment process that uses suspended growth of organism to remove VOD and suspended solids. The process requires aeration tank and settling tank. Part of the settled material, the sludge, is returned to the head of the aeration system to reseed the new wastewater entering the tank. What happens in the aeration tank? The wastewater flow into the large aeration basin where it is mixed with air to aid the growth of microorganisms that naturally live in the wastewater. Diffuse air into the tank from the bottom, creating bubble, or surface aerator can also be used. Pedal mixing, stir the water continuously. So yeah, this is the secondary treatment aeration tank. You can see here. This is the aerator. These are the aerator at the bottom of the tank. So when the wastewater flow in, so now this has become like this. Okay, how the treatment process happen? The microorganism called activated sludge clean the wastewater by digesting the organic material and other contaminants. Activated sludge consists of a mixed community of microorganisms that metabolize and transform organic and inorganic substance into environmental friendly acceptable form. The typical microbiology of activated sludge consists of approximately 95% of bacteria and 5% higher organism like protozoa, rotify, and higher form of invertebrate. And after that, they go to the secondary sedimentation tank. So next is wastewater into the basin called secondary clarifier, where the activities like settle out of the water. So some if it is used in the treatment process, and the rest is collected, thickening, and the water using large bell press that squeeze out the excess water. So this is like a sludge treatment. Excess sludge, which eventually accumulates beyond what is returned, is then removed from the treatment process to keep ratio of biomass to food supplies wastewater in balance. Okay, so if you use pond, so the pond, three type of pond, we have aerobic pond, we have facultative pond, and an aerobic pond. Facultative pond means anoxic pond. Okay, this is in between the aerobic condition and anaerobic condition. So different between pond. A lagoon is bulk of the oxygen in pond provided by photosynthesis. For lagoon, oxygen is provided by artificial aeration. This is for trickling filter. So this is a media. That's what I said about the gravel, not gravel actually. It's like, yeah, it could be gravel, big stone, big aggregate. So this is we call media, and the water will be spray on it. You can see here, the water will spray on it, and then something like this, and then after that We can inject the air also to increase the population growth of bacteria. This is an influent. Come in, spray, and then go down. This is trickling filter. And then after that, this is effluent. You can get a different effluent. Purifier and sludge here. Trickling filter. So this is trickling filter. So here, trickling filter. So this one is stone media, and this is under drain system, and this is effluent. A trickling filter consists of a bed of highly permeable media on whose surface and mix population of microorganisms in develop as a slime layer. You remember I said it's like a jelly layer. This is a slime layer. So the word filter in this case is not correctly used. For this no straining or filtering action to involve. Passage of water, wastewater through the filter cause development of gelatinous coating of bacteria, protozoa, and other organisms on the media. With time, the thickening of the slime layer increase, preventing the oxygen from penetrating the full depth of the slime layer. In the absence of oxygen, aerobic decomposition becomes alive, active near the surface of the area. The continual increase in the thickness of the slime layer, the production of an aerobic end product next to the media surface. The maintaining of hydraulic load to the filter eventually cause sloughing of slime layer on the start to form. This cycle is continuously repeated throughout the operation of the trickling filter for economy and to prevent clogging of the distribution nozzle. Thickening filter should be proceeded by primary treatment sedimentation tanks equipped with scum collecting device. And we have another one is a rotating biological contactor, OBS. So it consists of series of closely spaced parallel disc mount on rotating shaft which supported just above the surface of the wastewater. Microorganism grows on the surface of the disc where biological degradation of the wastewater pollutant take place. So something like this. You can see this is a rotating biological contactor. So half of this one will be submerged into the water, into the wastewater, and you can imagine one round. So the bacteria will grow on this contactor, and then when they submerge into the water, they will consume the organic matter, and then when they go up here, it will expose to the oxygen. So this is a this is a continuous process. So the moving of this contactor is slow. Okay, it's not that fast. Okay, so this one. So sometimes you need maybe 2 or 3. If one is not enough, you have to increase 2 and one more. But I think in Malaysia is last time is in Klang area. They use this OPC, but I think now they don't use this one because first of all it's the maintenance is high. The rotating pack of this known as the media contained in tank or through the or froth and rotate in between 2 to 5 revolution per minute. See that? 2 to 5 revolution per minute. It's very slow. Commonly use plastic for media as polythene, PVC, and expanded polystyrene. About 40% of this area is submerged in the wastewater. Biofilm, which are biological growths that become attached to the disc, assimilate the organic material in the wastewater. Aeration is provided by rotating action, which exposes media to the air after contacting them with the wastewater, facilitating the degradation of pollutant being removed. advanced level of treatment. Okay, so we will move to the tertiary treatment after a break.